Bolts are identified by length, strength, and the type of thread used. Identifying these areas will ensure using the proper bolt as a replacement. Bolt length refers to two areas, the overall length and the length of the threaded portion. The overall length measures from the bottom of the bolt head to the end of the threads. Thread length is measured from where the threads begin on the shank to the end of the bolt. Both of these lengths must be considered when selecting a replacement bolt. The strength of a bolt varies with the materials and heat treatment process used in manufacturing. Tensile strength is the rating given to the steel used to manufacture the bolts. A test machine pulls on a steel rod until it breaks. The tensile strength is how much force the machine used to break it. A system of grading allows the bolt strength to be identified. The Society of Automotive Engineers grades U.S. standard bolts on a scale of 1 to 8. Grade 1 being the weakest and grade 8 being the strongest. To identify the grade of a bolt, count the number of lines or marks on the bolt head and add 2. The bolt shown has 3 lines stamped in the head, indicating it is a grade 5 bolt. Hex nuts are graded in the same fashion. The number of lines or marks stamped into the surface indicates the grade. Always make sure the grades of the nut and bolt match. Metric fasteners are rated in a manner similar to U.S. standard bolts. Instead of lines or marks, they have numbers stamped on them in a common range from 4.6 to 10.9. The higher the number, the stronger the fastener. The threads on the bolt can either be coarse or fine. Coarse threads are farther apart than fine threads. Threads are identified by measuring the outside diameter and thread pitch. The outside diameter is measured using a micrometer across the high points of the threads. The actual measurement is usually less than the given thread size. How much less depends on the tolerance allowed in manufacturing. Measuring thread pitch requires using a thread pitch gauge or a steel rule. The thread pitch gauge requires matching the proper gauge to the thread pattern. This is the easiest method of measuring thread pitch. The steel rule method involves counting the number of threads per inch for U.S. standard bolts or measuring the distance between the threads for metric bolts. This method makes it hard to be accurate. Most bolts used in automotive engines are designed for a specific application. These bolts can vary in shank size, head size, thread pattern, and use an integral washer. Never replace these bolts with standard bolts. The features of the special purpose fastener allow it to meet the needs of a specific application. These bolts may not have a grade stamped in the head like standard bolts. Some specialized bolts must meet more rigid quality standards. More attention is paid to the methods used in manufacturing, the amount of control during manufacturing, and the selection of the materials. Less tolerance in manufacturing means the bolts will be more uniform in size than standard bolts. Particular attention is paid to features affecting the fastener's strength. Bolts have many uses, and certain devices help them apply the right clamping force. Improper use of these devices can result in the bolt breaking. When the application requires the bolt to penetrate the clamping surfaces, a hex nut works with the bolt. Remember, the grades of the nut and bolt must match. Again, bolt stretch and surface compression during tightening results in clamping force. The threads of the nut stretch with the bolt threads. Flat washers distribute the bolt load over a larger surface area. Be aware that flat washers have round and sharp-edged sides to them. The rounded side must face the bolt head. Installing a flat washer wrong causes the edge of the washer to gouge the bolt head, creating a weak spot. Under stress, this weak spot can cause the bolt head to break off. Mechanical locking devices prevent the nut or bolt from coming loose. These devices help in areas where varying loads and vibration are common. Cotter pins, locking tabs, and safety wire keep nuts and bolts from coming loose by preventing them from turning. Lock washers keep the nut or bolt from coming loose by applying tension to it. The added tension keeps the thread stretched when the stress on the bolt changes. Lock washers should be replaced after one use. Lock nuts cause a physical binding in the threads to prevent the bolt